Hello students. You might have noticed such kind of question that the examiner asks you that which of the following have highest internal energy, right? They will give you some options, and then they will ask you to compare the internal energy of the given species, right? So you would have a confusion, right? How to solve or how to approach such questions, right? You would have some kind of doubt. So how to solve such kind of question? If you want to compare that which one will have highest internal energy, how would you compare, right? That's what we're going to learn, and we will learn it very quickly. So the concept here is all about the internal energy. So if you remember the derivation of internal energy, we say that internal energy is a function of kinetic energy, potential energy, mass energy, nuclear energy, and electrons energy. Let me explain this part to you properly. What is it? Particles are in random motion, and that's why its energy persists due to its motion, that is called as kinetic energy. And the particles will have attraction, or they will have intermolecular forces, and that will lead to the potential energy, because they will have some bit of gap or distance between the particles. Such energy is called as potential energy. Obviously the particles will have mass, the protons, neutrons will have the mass, and that's why the energy will be called as mass energy. You can relate it with the Einstein equation, E is equal to mc square, right? Further, nuclear energy, very nice energy, like very important energy, because in the nucleus, the protons and neutrons stay together. Protons or the neutrons, and the protons or the neutrons and neutrons, they try to repel each other, because they are like charges. Like charges, we know that they repel each other, but still they are held inside the nucleus. They are bound inside the nucleus. They don't go away from the nucleus, which means that there's some force or some energy involved, and that is stopping them to go, not to go away, right? That is stopping them or preventing them to go away, right? And then electrons, and we know, we have studied about the electrons, that in the atomic structure, that the electrons jump from one shell to another shell, and they release energy. In that case, like when they absorb energy, then they go to the higher energy level. That's okay, that's fine. But the concept is, as we know, like the energy of the electron in every shell is fixed, right? That is, E is equal to E naught value, and n is z square upon n square, right? We know this value for hydrogen atom. Let's say the first shell, the energy value will be minus 13.6 electron volt, right? That we know this, all this. So basically, and another thing is, electrons repel each other. So these energy are involved, right? And we know that such energies are tough to calculate. So if we overall compare, we know that in kinetic energy is temperature dependent. So can I say that internal energy depends or is a function of temperature? And second thing, mass energy. So mass can be expressed in terms of moles. Say yes or no. That means internal energy is a function of moles. Can we say this way or not? And suppose if we assume it to be an ideal gas, then for ideal gas, the force of attraction is assumed to be, intermolecular force is assumed to be zero. And in that case, the potential energy is zero. But for any other real gas, then there will be some potential energy. So basically, the energy depends on the nature of gas also. Say yes or no. So if we overall conclude, we can conclude that the change in internal energy, that depends like moles, heat capacity, and the delta T, change in temperature. Or overall, if we say, we compare these, we can say that internal energy depends on moles, CV, heat capacity at a constant volume, and the temperature. So if moles increases, internal energy increases. If heat capacity increases, internal energy increases. And if temperature increases, then internal energy also increases, right? These are the parameters. So now we're gonna see the option. The first option, 2 moles and 300 Kelvin, 56 gram of nitrogen. Nitrogen's molar mass is 28. You know that very well, right? So 56 divided by 28, you will get 2 moles and 300 Kelvin. 8 gram of oxygen. Oxygen molar mass, O2 I'm talking about, that is 32. So 8 upon 32, that will be 0.25, 1 by 4. And again, the temperature is 300 Kelvin. But if you look at the last option, 2000 moles and 900 Kelvin, both factor is larger in case of fourth option, and that's why the fourth option will have highest internal energy. So the right answer will be D. I hope you have understood how to solve such kind of questions. Thank you very much.